Bismillahirrahmanirrahim. Uh, Today we will start our new lecture. In this lecture, we will calculate some important statistical parameters that are always used in any research paper and any research work. The most common statistical parameters that are used for any data, which are minimum value, first quadrant value, median, third quadrant, maximum, standard deviation, range, sum of the data, count of the data, then variance, covariance, skewness, kurtosis, etc. And this lecture we will start. These parameters will be calculated for the specific data which you have from the different experimental work or from the observed data. We will start one by one by doing by calculating these parameters in R. The first one is the summary of the data, and we will do one by one. Let us start this package. If you want, the first one is the summary of the data. If you want to find the summary of any observed data or experimental data, suppose I have the data which name is the correlation matrix, and the columns data which are present in this matrix is pH value, TSS, total dissolved solid, total suspended solid, then electric conductivity, then dissolved oxygen, BUD, CUD, turbidity, etc. And I want to find the summary of this data. So just write summary. The first step you will be the attach file, which is the correlation matrix, and the correlation matrix is actually the name of the data. You can upload any if you upload your data to the R, you can give any name to this to your data. I give the name is correlation matrix. So you can see the data as BUD, CUD, and the mentioned titles. So I want to find a summary of my data, which is the correlation matrix. When I click on it, you can see the correlation, the summary of my data, which is the pH. You can see the pH is almost 10 values, and you can see the minimum of which is 6.93. The first quadrant is 6.98, then the median value is this, mean is this, third quadrant, and maximum value. So this is actually the parameters of the first column. Then similarly, in the second column, you can see the minimum value, first quadrant value, median, mean, third quadrant, maximum, etc. Similarly, you can see the summary of each column. This is the you just click on it, you just control copy it and paste in Excel. So just copy it and paste, control C and paste in Excel. So this is the summary of the data. Now you can also calculate these summary parameters one by one, which is separate of your data one by one. Suppose I want to find the minimum value of my data, which is the correlation matrix, but as you can see the correlation matrix, there are a lot of 1 2 3 4 5 6 7 8 different columns, and I find the minimum value of the first column. So you just type and shift 4. I want so you can see the list. Just click on it, and you can see the minimum value of the first column. When I click only the correlation matrix without the end, you can see 0. 0 means you can get the minimum value of your all the columns. Let's suppose there are 10 columns and the minimum value of these 10 columns is 0. So you can get the minimum value of all the matrix, all the data. Similarly, you can find the maximum value of the correlation matrix. Correlation matrix means the my data name, which is I find, suppose I want to find the maximum value of this total dissolved solid, which is the I guess the third column. And when I click on it, so this is the maximum value and the third column. So this is the summary part. The next one is the so the minimum, first quadrant, median, third quadrant, maximum. These are covered. Now for you can also find the range. This is my code. You can also find the range, also can find the sum of the data. Suppose I want to find the range of my data. So my data is the correlation matrix, and I want to find the range of suppose the pH, the first column, and you can see the range means the maximum value, the minimum value, and the maximum value. So this is the minimum value and this is the maximum value, which is called the range. Similarly, if you want to find the sum of your data, and which is the correlation matrix, suppose I want to find the sum of this data, and when I click on it, so you can see the sum of your data. This is called the sum of the data. The third one is suppose I want to count the number of values present in each column. Suppose I want to count these values. If you have a big data, so then it is very difficult to calculate, to count the numbers in each column. Suppose I want to count these numbers. So for count, you can just type length and which, 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 and then the data as the correlation data matrix, and then pH. When I click on it, you can see error as log, which is not logical. Suppose this is I want to count is less than suppose 6. This is 0, and the pH, you can see the value less than the value, and suppose I want to find the value suppose in TSS, which is suppose greater than 10. Suppose this is the code. This means that the value of total suspended column, which is greater than 10, the count, find the count of these data. I mean that if there are the almost 10 values, and find out the count of those values that is greater than 10. Just click on it, so you can see there are 7 values whose value those value are maximum than 10. You can also use this text, suppose equal to, suppose I want to find the exact 31. This is I want to find the value which is present in the total suspended solid TSS column, which is exactly equal to 30, and I want to find that value the count of that value. When I click on it, you can see the 1. If there are more than more 30 values, you can see the count of that value. You can also find out the sum of, suppose I want to find the sum which which is the correlation matrix, the name of the data. Suppose I want to find the suppose turbidity, and the value is suppose greater than 1. So this text means that find out the sum of the correlation matrix and the special column which is named as turbidity, and find the sum of the values that is greater than 1. And you can see the greater than 1 is 1, 2, 3, 4. Four different values which are greater than 1, and you can see the sum of that values, which is 27. So you can see this 2, 16, 4, 20, and this is 22, and 23, 24, 25, 26, 27. So the sum is 27. Similarly, you can also find the mean of the data, which is the which is the correlation matrix, the name of the data. And I want to find, suppose, the total dissolved solid. Find the mean of the data, which is suppose is greater than, is less than 8. So this text mean that find out the mean of your data, which is the correlation matrix, and the sub column, which is the total suspended solid, and find out the mean of that values that are less than 8. So if you take this value is 20, 25, suppose, and you can see the mean of this total suspended solid value. So this is the count of in each data. The third one is the suppose I want so this is the percentage of the data. You can see 100 multiplied by length, then data name, then the total dissolved solid is less than, suppose, 200, divided by length of the correlation matrix. The sub column is the total dissolved solid. So this is the correlation. This is basically the percentage of any data. This is the correlation matrix data. The sub column is the total dissolved solid, and I want to find the percentage of that values, that count, which is less than 200. So you can find the values and the total dissolved solid, those values that are less than 200. So just find out the percentage of that count. It means that to find out the percentage of the total dissolved solid values that are less than 200. So you can see that 80% of this data is less than 200. You can also give any value to it. So this is the length of the count of the data. Then for now I want to find the some other parameters, some other statistical parameters that are necessary for any research paper. For that parameters, I just want to install the package which name is moments, moments. Moments. Just click on it and you will see you can install this package, but all of this but I've already installed it, so you can just upload it and load it this package. So just upload the this package which name is moment. And now when you upload this package, so now you can find the variance of your data, which is the correlation matrix, the name of the data, and you find the suppose I want to find the variance of my data, which is the total suspended solid. The variance is 60.48. This is the variance of my data. Suppose I want to change the correlation matrix, and I want to find the correlation of suppose electric conductivity. When I click on OK, you can see the variance of my data. The sub value is electric conductivity. Then I also find the standard deviation of my data. Standard deviation SD. You can see what is the shortcut for standard deviation. SD of my data correlation matrix, and I want to find the suppose pH. When I click on it, so you can see the standard deviation of my data, which is the correlation matrix, and the standard deviation of the first column, which is the pH. Similarly, you can also calculate the standard deviation of any column, any data, correlation matrix, and sub data is suppose total suspended solid. You can see the standard deviation. You can also calculate the standard deviation of each column by the same procedure. Similarly, also find the variance of by the same procedure. Then the third one is the correlation. But for the correlation, you can upload the data and find out. Suppose if you want to find the correlation between the pH and the total suspended solid, just write the name of these data. Suppose I want to find the correlation of correlation matrix between the pH and correlation matrix, which is the total suspended solid. When I click on it, you can see the correlation value, which is between these two columns. The first one is the pH, the second one is the total suspended solid. If I want to find the correlation matrix, when I find the correlation matrix of suppose I want to find the correlation of the total suspended solid, and suppose I want to find the correlation of turbidity, which is this total suspended solid and turbidity. So when I click on it, you can see the correlation value, which is the 0.593. So this you can also click on it and just chemical correlation matrix, which is the data, and just click on it. You can see the correlation value of each one of the parameters, each one of the data that each columns that present in your data. You can also check. Suppose I want to find the correlation of my data, then I want to use the method of Pearson method. You can see these values are the Pearson values, correlation values, but that are the dependent on the Pearson method. Suppose I want to change my method, which is the Spearman method. Just click on it. You can see the values that are depend on the Spearman method. Similarly, the Kendall method, uh, sorry, I think the spelling is wrong. Kendall method. This is the, you can see the value. The Kendall is Kendall, Kendall method. So you can see these three different techniques for the correlation matrix. From onward, the third one is the skewness of my data. Suppose I want to find the skewness of my data, so you can skewnesses of my data, which is the correlation matrix, and pH. When I click on it, so you can see the first column skewness value is 1.2362. Suppose I want, we can just see on a, you can see the summary of skewnesses of all the data, which is for pH, this is the skewness value is 1.2, for total suspended solid 0.02, total suspended solid is minus 0.04, electric conductivity is 0.4, total dissolved solid is 0.64, BOD is 1.4, COD is 1.35, turbidity is 2.5. So this is the skewness of my data. Similarly, you can also find the kurtosis of any data. Suppose I want to find the kurtosis of my data, which is the correlation matrix, and I want to find the kurtosis of my complete data. So the pH kurtosis value is 3.7. This similarly, total suspended solid is 2.2. Similarly, total dissolved solid is 2.9, and each one is given. And if I want to find the kurtosis of any specific data, suppose I want to find the kurtosis of the first column, so you can see this value, which is 3.74, and you can also get this value as for the first column. This is the kurtosis of any data. In the next video, I will show you how to plot different regression models, which is R-square value, root mean square errors, and many more that are used for the validation of any statistical data. So we will see inshallah in our next lecture.